All right, guys. This lesson from Module 5 is actually not really out of your book, but kind of covers an important concept. So, comparing linear equations. So, what we like to do when we compare linear equations is we like to compare their slopes and compare their y-intercepts. So, we're pretty comfortable looking at slopes, but let's look at the right and calculate the slope. So, this is just a set of points, so an x and a y coordinate, an x and a y coordinate over and over and over. Remember, we have a slope formula that if I have two coordinates, I can find the slope. And here's kind of the cool thing. As long as you pick points from the line, it doesn't matter which 2 points you pick. All of these points are on the same line, so you just need to pick two. I'm just going to pick the first two. So I'm going to use the point -5, 3 and -4, 1, and I'm going to use my slope formula. So m is y minus y over x minus x. Okay, simplify. So m is equal to -2. -4 plus 5 is 1, so my slope there is -2. So it would be slanting downward. Okay, look at this graph and calculate the slope. So I want to pick two nice points. Sorry, this graph is pretty faded, you guys. Looks like it's crossing at 1. And I want to find another nice point. I think that one is a nice point. Okay, so calculate my rise and run. So I go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So my slope there is +4/5 because my line is rising. Compare the slopes above. Which function, a or b, is steeper? So anytime we have a fraction that's less than 1, we are going to say that it's a shallower slope. Another way to compare that is to look at the absolute values. So don't pay attention to positive, negative, but just look at the numbers and ask yourself which one is bigger. So 2 is quite a bit larger than 4/5. That is going to be the steeper slope. So A is steeper because 2 is larger than 4/5. So even though it's negative, that didn't really matter for steepness. It's just going the opposite direction, but it's still a steeper line. All right. We're going to do the same thing here on number 2. We're going to calculate the slope of each. So just like we did before, I'm just going to use 2 of the points. So I've got 2, 3, and 3, 4. So I'm going to do y minus y, so 3 minus 4 over x minus x. So I get -1 over -1, which is just 1 for my slope when I reduce that. Slope of this one, I just look at the number in front of x because it's in slope-intercept form. So my slope of this one is 3. Which one of these has a steeper slope? Again, I just ask myself which number is bigger. 3 is larger than 1, so B has the steeper slope. All right, number 3, we're going to look at the same things. Slope of this guy is 2. It's the number in front of x when it's in slope-intercept form. This graph, pick kind of 2 decent points. This is another one that's kind of tough to see. Sorry, guys. So it looks like 1, 2, 3, 4, and over 1, 2. So rise and run was 4 over 2. So 4 over 2, though, I could simplify that, right? 4 over 2, I can simplify that to 2. Are the slopes of the functions above the same or different? So these are the same. After I reduce it, I still get 2. So these are the same. All right. Okay, so we are going to fill in whichever piece is missing. Okay, so we are going to, they gave me the equation, they gave me a table of values, we are going to graph this function. So I would say that, well, we've done this both ways actually, guys. You could graph those 4 points and connect your 4 points, or we've learned how to graph just based on looking at the equations. Start with a y-intercept of 4, and the slope is 2 or 2 over 1, so I would go up 2 and over 1. And it's positive, so I should be going upwards. So up 2 over 1, connect our line. So you could graph it either way. Plot those 4 points or just look at the equation to get the information you need. All right, this one, we're missing 2 pieces. We are missing the graph and the equation. So I'm going to start by just graphing those 4 points. Since we don't have the equation to do that from, we can easily graph those 4 points. So I've got -1, 2, 0, -1, 1, 4, 1, oh, 1, -4, I'm sorry, 1, -4, and 2, -7. I think I'm off on that. 2, -7. All right, so there's our line. All right, so a couple ways we could do this one. Well, we can easily see the y-intercept. It's -1, or you could have picked out, when x is 0, that's my y-intercept. So we know we have a y-intercept of -1. Now the slope, we could either do our slope formula using 2 points, or we can count rise and run. I'm going to count rise and run. So looks like the rise is 1, 2, 3, and the run is just 1, but it's a negative slope because it's going down. So -3 is going to be my slope, and then my y-intercept was -1. All right, last one here, we are missing the graph and a table of values. So I'm going to graph it first because we know how to graph from the equation in slope-intercept form. Our y-intercept is 2, so start with that guy. And then up 3 over 2, rise of 3, run of 2. I'm going to go up and over because I know it's positive. 1, 2, 3, 1, 2. Sorry, that's hard to see. All right, so there is my line. So table of values, we could do this a couple ways. I could just plug in some x's and get the y's. We've done that before. Or I could keep my slope going up 3 over 2 and see what points I hit. Totally up to you. So I'll do an example of that. So I already know 2 points. I know 0, 2. That's the y-intercept. This point is 2, 5. And let's see, so if my rise is 3 and run is 2, I could go down 1, 2, 3 and over 1, 2. So this, my line's not very straight, sorry, it should be at that point, which is at -1, 2, or sorry, -2, -1, x first. And then I could keep it going up this way too. So right now I'm at 2, 5. I could go up 3 and over 2 again. So it would be up at 8 and over to 4, I believe. Okay, or if I didn't do that, I'm going to show you guys the other way to do that. So if I didn't kind of keep my slope going to get the points, especially since this graph is really faded and hard to see, I could just pick an x. So I'm just going to pick 4. I'm going to pick 4. Okay, so when x is 4, what is the y that goes with it? So we did this when we were graphing from a table. I'm just going to plug in 4, and I'm going to write it as 4 over 1. So that I can multiply with my fractions there. And then we just simplify. So 3 times 4 is 12. 2 times 1 is 2. And then 12 divided by 2 is 6. So I get 6 plus 2 is 8. So when I plugged in 4 for x, I got out 8. So that would be another way to find points to fill the table. All right, that is all for this comparing linear functions video.